In problem 1851, we have a cyclic process in which, starting at point A, we have an adiabatic expansion to point B, a constant volume process to point C, and then an isothermal process back to point A. We're given that this is an ideal gas. Gamma for that's 1.67. The pressure at A is given, and the volume of A is given, and the volume at B is given. And what we're to find is the pressure at B, the pressure at C, and the work done on the gas as we go around this path, this cyclic process from A to B to C back to A again. To find the pressure at B, we use the equations for the adiabatic expansion from A to B. And for that, the relationship between the pressure is that the pressure times the volume to the gamma power is constant. So we have this expression in which we have to solve for B, given the pressure and the ratio of the volumes. So we can simply write the expression this way, take the natural log of both sides, and then plug in this case, gamma and the ratio of the volumes. And we arrive at this expression. And if we exponentiate both sides, then the pressure at B is 0.160 of the pressure at A. You can plug in the two values, and the pressure at B is 39.9 kilopascals. In part B, where we want to know the pressure at C, then we can use the isothermal process from C to A, which gives us the relationship between the pressure and the volume, since the temperature is constant. So all you have to do is solve this expression for the pressure at C, insert the values for the volumes and the pressure at C is equal to 83.3 kilopascals. Then in C, where we want to find the work around the path, we break that up into three contributions, one along the path from A to B, then from B to C, which is 0 because it's an iso volume or a constant volume process. And so no work is done in that process, and then the work from C back to A. The work from A to B is given by the work equation for an adiabatic process, and the work from C to A is given by the work expression for the isothermal process. And remember that nRT in the isothermal process is just the pressure times the volume. And we can insert this for this. And so the work from C to A is just minus the product of the pressure times the natural log of the ratio of the volumes. And so if you put the numbers in for the pressure, the volume, and take the natural log of 1/3, then the work from C to A is 275 joules. Now the work from A to B is simply inserting the values into this expression. And so when that's done, when the pressure and the volumes are put in and divide by gamma minus 1, then the work from A to B is minus 194 joules. So the combined work on the gas is 81 kilojoules.